Okay, we are going to continue with translating expressions. We've looked at translating numerical expressions, and today we're going to translate and evaluate algebraic expressions. The difference would be is this time we're going to have some unknown numbers that we're going to represent with variables. So when you're taking your notes, this is the first section. Here in the left column, you will see an equation. So what we have here are 5 different ways that we could read this equation. So for the n, or any variable that you choose, we're just saying a number. We don't know what the number is, so we just say a number. And then we have to have a way of saying that we're going to add. And here are 5 different ways that you can say that. This expression could be read a number plus 5, because plus means to add. The sum of, because the sum is the answer to an addition problem, a number and 5. A number increased by 5. 5 more than a number. 5 added to a number. Or you could say a number added to 5, or a number more than 5. So again, the numbers that we filled into the blanks here are just synonyms, different ways to let you know that we are going to be doing the operation of adding. And instead of having all the numbers in place of a number, we have an unknown number, so we just say a number. Otherwise, it works the same as the numerical expressions. So with subtraction, here's our expression. Notice that we have an unknown number right here, so in place of that, we're going to say a number. So what are 4 different ways that we could read the same expression? We could say a number minus 10. We could say a number decreased by 10. 10 less than a number. Remember we talked about this phrase, and when you use the phrase less than, it flips, so the 10 is at the end. So we say 10 less than, and then the number's at the first, but we say it last. Remember how that phrase less than, you flip what you actually see? Important to remember that. And 10 subtracted from a number. So 4 correct ways to write that expression. Let's look at multiplication. Here in the left column we have, this is the expression we have. So what are 4 different ways that we could read that? We could say 2 times a number. We could say the product of 2 and a number. Because we're multiplying specifically by 2, we could say twice a number or even double a number. All of these are 4 accurate ways to read that multiplication expression. Now we have this expression right here, 1/2 times y. So we could just read that 1/2 of a number. Remember, the preposition means to multiply, so 1/2, you're multiplying 1/2 times a number. Down here, the last, we have y squared, so it's just a number that we don't know, squared. So when you have a variable and you don't know what that number is, you just say a number. Let's look at 2 different ways that we can read this division expression. We could say a number divided by 4 or a number separated into 4 groups. So this is translating algebraic expressions. So let's look at this would look like. 2 inches shorter than Catherine's height. We do not know Catherine's height, but we want 2 inches shorter than that. So since her height is unknown, we need a variable to represent that. We could just have h for her height. 2 inches shorter than that is going to make it minus 2. So you just have a variable decreased by 2, or a variable minus 2, or 2 less than a number. The quotient of some number and 13. We have learned that a quotient is the answer to a division problem. So we know we're going to have a division problem. Some number, that's our unknown number, it goes on top. And 13, whatever they say last, goes on the bottom. So the quotient of some number and 13 is x divided by 13, or whatever variable you choose. 8, so in place of 8, we write the number 8. More than refers to a plus sign, so we say plus. The product of means that we're going to multiply. What are we going to multiply? A number and 4. So when we do that, I'm going to write 4 in. You want a number times 4. But the way that we always write that is we always write the number before the variable. We call it the coefficient. So instead of writing n times 4, we just write 4 in. We flip it. It still means 4 times a number, but that's just the way we're going to write in algebra. So when you have multiplying a number and a variable, you put the number first, followed by the variable. Half, remember we talked about half as dividing by 2 as many pieces of candy. So we can have a variable representing the candy, and we're going to divide it by 2 or take half of it. Twice, remember, is multiplying times 2. Twice, remember the sum of means that we need a set of parentheses. And what is inside of there? A number and 5. A number and 5. Twice the sum of a number and 5. Now you can see that I wrote in, but the b, it doesn't matter what variable you use. It just represents an unknown number. 60, so we write the number 60. Added to is an addition. 11, we write the number 11 minus a number. Straightforward. We just read from left to right and replaced the words with numbers and operational symbols. Left to right, it says 15 minus, so we simply write 15 minus the sum of, there's our set of parentheses, and what do we put inside? A number and 40, so we're adding a number plus 40 in parentheses. 7 more than, so we write 7, and more than is addition. 2 times a number, we're doing 2 times a variable, so we write the 2 and then write the variable, 2x or 2n, whatever variable you choose. The square of, the product of 6 and a number. The square is an exponent, so we know we're squaring or have an exponent of 2 on what? The product of 6 and a number. So we're multiplying 6 and a number, and then we're squaring it. Now, since we want to square the entire phrase, we need to put that in parentheses so that we know we need to do this operation before we do the exponent. Now we're going to practice plugging in numbers to our algebraic expressions and solving using PEMDAS. So our equation is 3a plus 4d. If a is equal to 7, we're going to plug in a 7, so that would be 3 times 7, plus d is equal to 5, so it would be 4 times 5. Now, according to our order of operations, remember PEMDAS, parentheses first, exponents, multiplication, division in the same step from left to right, addition and subtraction in the same step from left to right. We're going to do our multiplication first. That would be 21 plus 20, and then we add, it would be 41. Okay, filling in numbers, if a is equal to 7 and b is equal to 9, in our first set of our parentheses, we have 7 plus 9. There is no operational sign here, so we know that's an understood multiplication. In this set of parentheses, we have c plus d, which is 2 plus 5. Now, according to our order of operations, we have to do parentheses first. So we're going to evaluate this set of parentheses and this set of parentheses. 7 plus 9 is 16. And then the second set of parentheses is 7. So we have 16 times, there's no operational sign there, so it's an understood multiplication, 16 times 7, which is 112. C is 2, so we're going to plug that in, and we're going to plug in 5 to D. Here's D is 5, C is 2. We always do our parentheses first according to order of operations, so we have 2 times 9, and then we multiply and get 18. So we're just plugging in numbers and following our order of operations that we've been talking about. A company rents a house for $200 a day, plus an extra $30 per day. So it's $200, I said a day. It does not read a day. A company rents a house for $200. So the initial fee is $200 plus $30 per day. Per is, it doesn't say the word per, it says $30 a day. It means per day. So we're going to multiply $30 times the number of days. $200 initial, $30 for each day or per day. That's the expression. Now, we can plug in the number of days. Let's say they decided to stay there for 6 days. So that would be initially $200 charge plus it's $30 for each day, and they decided to say 6 days. So remember, we do our multiplication first. So you have your $200 plus 30 times 6. So go 6 times 3, add a 0, which is 180. So altogether, that would be $380 to stay there. So this was help on evaluating and translating algebraic expressions.